But you know what? No, this is Raw Footage Season 2. Hi, I wanted to make a video. Sorry I haven't been uploading. In a while. I just got bored of Kerbal Space Program, but I wanted to make this video about black holes because I've been doing a lot of research about black holes recently. And they're really cool. I used to think that they were overrated objects in space. And that, they're just kind of simple. Yeah, they're really strong, whatever. So, I was doing research and they're really, really cool. So, first, I don't know how to start it, but have you ever looked at a picture of a black hole and see how it has the secretion disk? But then on the top, it looks like it almost has like a secondary secretion disk across the top and the bottom. That is not actually a second secretion disk. It's actually the light coming from the backside of the secretion disk. The light is obviously coming from beyond the event horizon, so it doesn't fall in yet. So it curves around to meet your eyes. But also, if you were really, really, really close to the event horizon, you would also, if you looked up, you would see your feet. If you looked down, you would see your head. And if you look to the left, to the right, you would see the sides, because the light orbits around the black hole and meets your eyes again. So, yeah. But also, that's just assuming the black hole isn't rotating. All objects in the universe, once in motion, must stay in motion unless a force is acted upon them. That's including angular momentum. And so when you have a neutron star that's rotating 100 times per second that collapses into a black hole, you have to keep it has to keep its angular momentum, so it rotates, so the black hole rotates, and its singularity is a singular point in space that really can't rotate. So when you rotate, so it has to become what's called a ringularity, which still has infinite density, but it pulls on space-time in a spiral. So when it pulls on a space-time in a spiral, say this is a black hole and you had an object falling in, this is like a non-rotating black hole, it falls in, it just goes straight to its singularity. But if it's spinning, it goes into it. So that's the straightest possible path, is to enter what is called the egosphere. Now, only rotating black holes have it, which is practically every single black hole. And it's where space is like spinning. Now, if you're in the egosphere but have not passed the event horizon, which is this, and you do it just right, you can actually escape it if you leave enough mass of whatever, say your spaceship or whatever, behind. You can kind of throw yourself back out of the egosphere. It takes a lot, I think. But now, the egosphere is only rotating about 99% the speed of light. So if it was faster than the speed of light, which is impossible, but let's say this black hole was special and it somehow did the impossible by having an egosphere faster than the speed of light, then the event horizon would never actually exist in this theoretical black hole, because it's because any light that comes in would just be like thrown back out, which would cause something called a naked singularity, or ringularity, because it's rotating. And yeah, it's the singular. I know, it's just something off my desk, but it's pretty cool about black holes.